Hello, beautiful people. So we're going to go ahead and go over our homework 7 notes 1. So we have these warm-up questions here. I'm going to go ahead and do one with you. You can work on the other one. So gas price last year was $4.50. This year it is $6.75. So we want to know what the percent increase was of last year's price. So we are going to take this year and we're going to divide it by last year's price. So this year's $6.75 divided by $4.50, and this is going to come out to 1.5. So if I change 1.5 to a percent, that's moving the decimal 2 places to the right. That is going to be 150%. Okay, so this year's gas price is 150% of last year's gas price. In other words, there is a 50% increase, right? Because 100 is just 100, and then you're increasing at 51%. Okay, so to calculate this year's gas price is going to be equal to the decimal that we got, 1.5 times last year's gas price. So just basically 450 times 1.5 will give us the 6.75. All right, just pay attention that this one is a decrease, so you will be getting something that is less than 1, which is what you want. Increase should be more than 1. Decrease should be less than 1. Okay, so we're going to be revisiting arithmetic and geometric, so we're going to determine whether the values is arithmetic or geometric. So remember, arithmetic is if it's adding by something constantly or subtracting by something. Geometric is if it's multiplying by something. Okay, then we're going to write the linear or exponential equation that best models the table of values. This is something that's going to be really much a review and a recall from Algebra 1. Don't worry, that's what this is all about. Okay, so I can obviously see that this side's going by ones, and this side from 160 to 400, that's I'm adding 240. From 400 to 640, I'm adding 240. So if I'm adding the same thing, this is going to be arithmetic. The shape of the graph is a line. And let's say I sketch out my graph, right? I'm going to be starting at 160. That's my y-intercept, and it's going to be going up in that direction, right? And it's going to, since the slope is 240, it's like I'm going to be running 1 and then rising 240 to the next point. So this one would be 400, right? And then it would be like 1 right here. So that's just like an easy little sketch. It's going to be U0 is equal to 160, and then UN is equal to UN minus 1 plus 240. And then the explicit is when it's f of x, or y, okay, is equal to the y-intercept, which is 240. No, not 240, sorry. Oh, let's just, okay, 240x plus 160. So our slope is 240, our y-intercept is 160. If I look at this side, I'm adding 240, but then I add 600. Okay, so this is not good. So now we need to look at what is it multiplying by, right? So to figure out what it's multiplying by, I'm actually going to take 400, and I'm going to divide by 160. Okay, if you divide that, you're going to get 2.5. Okay, so that means instead of adding 240, adding 600, what we need to say is that this is multiplying by 2.5. This is multiplying by 2.5, and so on and so on. So this is geometric. The shape of this graph, okay, it's still going to have a y-intercept of 160, but it's going to have a curve to it now. Okay, and so we need to write that. It's going to be curved. So it's going to still be U0 is equal to 160, UN is equal to UN minus 1 times 2.5, okay? We never really looked at the shape of the graph when we did geometric, okay? All we talked about was the recursive formula, whether it was arithmetic or geometric. We looked at the table and we wrote the explicit. But this is going to be f of x is equal to our initial value times our constant multiplier, okay, to the x power. Okay, since it is exponential, you're going to have an exponent of x. All right, so write an equation that models the table of values. Well, if I know that zero number of cuts, if we're talking about a piece of paper, right? Zero number of cuts in one sheet of paper. Well, if I was to cut a one sheet of paper, right, I would make one cut. I'm now going to have 2 sheets of paper. If I take those 2 sheets of paper and I make 2 cuts, I'm going to have 4 sheets of paper. So right here, we can see that this is times 2 times 2. So let's keep timesing 2. 4 times 2 is 8. 8 times 2 is 16. 32, 64, 128, 256, 512, and 1024. And I'm just, every single time, making one more cut. So all these are going up by 1s. Okay, and we can also graph that. So 0, 1, and I think these are going by 2. So 0, 1, and then 1, 2. Okay, and then we have 2, 4, 3, 8, 2, 4, 6, 8, 4, 16, so 12, 14, 16, 5, 32, 6, 64. Okay, and that's all that's going to fit. And when you graph those points, if you didn't know what the shape of this graph is going to look like, well, if you graph these points, you're going to see it is going to be that smooth L curve. Okay, so when we write the equation, it is going to be f of x, or we can do it as y. Okay, remember, it's the same thing. But these both represent the number of sheets. Okay, number of sheets of paper. Okay. We're going to start with our initial value. So when x is equal to 0, it's 1 times. It's always going to be times. What is our constant multiplier? Our constant multiplier is 2 raised to the x power. Okay, so that is like the parent function of an exponential function. We talked about parent functions for transformations. This is the parent function of exponentials. Okay, so when I go to the back, okay, we have 2 different forms of exponential functions. Y is equal to a times b to the x. If you could just, okay, so we have 2 different forms. We have exponential growth and we have exponential decay. So y equals a times b to the x. This is the general form. The a is the initial value. I'm going to put IV, and then the b is the constant multiplier or constant ratio. All right, so we have exponential growth, meaning that we're going to have our initial value, and in here it's going to be 1 plus our rate. Okay, so this r is the rate. Right? So we're looking for things that are going to be greater than 1. And so remember, our general form was a times b to the x. Well, this 1 plus r, this all represents b. Okay? This b is going to be greater than 1 because you're adding 1 to it. So if the rate was 0.3, then b is 1.3. So for exponential growth, it's going to be greater than 1, the b. All right? So again, example, if my r is equal to 0.5, right, then b, right, this whole thing is b, is going to be 1 plus 0.5, which is 1.5. So my constant multiplier, which I'm multiplying by, is 1.5. And it is always going to be, we have our a, and then it's going to be growth. Oh, that was a horrible looking example. But it's going to be rising, okay, from left to right. Now decay, all right, this is still our rate. But decay, obviously, now we're looking at something that is going to be going down. This is still representing b, and b is going to be in between 0 and 1. All right, so not necessarily a negative number, but it's between 0 and 1, right? It's less than 1, but it's greater than 0. So let's say our r was 0.15. Again, our b is going to be equal to 1 minus 0.15 because it's decay. It should be minus. So then this is just going to be equal to 0.85, all right? So then if our a is right here, this would be coming down, right? It's going to be going down from left to right. So now we're talking about a b. The b is going to be less than 1, okay? This is less than 1. So now we're going to determine whether each function represents a growth or decay. So looking at the multiplier, I have y equals 1/5 times x. That is what's going to determine whether it's growth or decay, is based off the multiplier. So 1/5 is less than 1, okay? So this is going to be decay. And so now we're going to find out what r is. So if b is equal to 1/5, that is just 0.20, okay? That's what b is equal to. Now we're going to go backwards to solve for r, right? So again, b is equal to 1 minus r. So 0.20 equals 1 minus r. I'm going to subtract 1 on both sides. That is going to give me negative 0.80 equal to negative r, but divide by negative on both sides. So r is equal to 0.80. So 0.80 is my rate. Okay, and then just a quick, if there's no number in front, that initial value is just 1 right there. So there's our A, and that's our B. All right, let's look here. Here's our A, initial value of 3, and then there's our B, a constant multiplier of 4. So greater than 1 is going to be growth. And again, we're going to have 4 equals 1 plus r. So we're going to subtract 1, subtract 1. So 3 is equal to r. So our rate of change is 3. All right, here's our A. That's the initial value. Here's our multiplier, B. 1.2 is greater than 1, so this is growth. And again, 1.2 is equal to 1 plus r, because this is B. So we're solving for r. Subtract 1, 0.2 is equal to r. All right. Write an exponential function that passes through the points 1, 6, and 3, 54. So here's our general form. Y equals a times b to the x. Well, let's put these on our table. Let's make a table. So we have 1, 6, and then 3, 54. Well, we know we're going to have 2, and we know we're going to have 0. So we need to figure out what that is first. So if I do this, I know I'm going to have times b. I'm going to get whatever 2 is, and then I'm going to take that number and multiply by b again. So we are going to have 6 times b is equal to 54, which is 6b squared equal to 54. I'm going to divide both sides by 6. B squared is equal to 9. I'm going to take the square root because that is the inverse of squaring something. So b is equal to 3. All right, so that means I'm multiplying by 3 each time. Right, so instead of times b, this is times 3. So 6 times 3 is 18. 18 times 3 is 54. Well, to go backwards, if we're multiplying by 3, then we need to go backwards. We're going to divide by 3. So 6 divided by 3 is 2. And if I go forward again, 2 times 3 is 6. 6 times 3 is 18. 18 times 3 is 54. So now we have exactly what we need. We have our multiplier, okay, and we have our initial value. So we're going to take those two things and write the equation, which will come out to y equals 2 times 3 to the x. All right, calculate, graph the exponential function below that models the value of a car based on years. So calculate the decay factor, so the b, and then in other words, the car depreciates by blank every year. What's the initial value? The a, write the exponential function, blah, blah, blah. All right, so first off, initial value. Let's start there. So if I'm right here, and 5, 10, 15, 20, this is going to be going by, oh, this is going by 2. So this is 32,000, 34, 36. So the initial value was $36,000. That's how much they purchased the car for. Okay. Now, let's see what it is that we're decaying by. So if I set up my table, I have 0, 36,000, 1, 28,800. That's enough. I mean, I could keep going, but it's going by 1. Let's figure out what we're multiplying by. So to find out what we're multiplying by, we're going to divide. We're going to take 28,800. 28,800. We're going to divide it by 36,000, and it's 0.8. So the decay factor is 0.8. That's our B. So remember, B is equal to 0.8, and B is equal to 1 minus R. So 0.8 is equal to 1 minus R. We're going to subtract 1, and we're going to get negative 0.2 equals negative R divided by a negative on both sides. So R is equal to 0.2. All right. So that means it is decreasing by how much each year? Well, it's not decreasing by 80%, right? It's decreasing by, what is it getting, what's the rate right there? 0.20. And 0.20 as a decimal, I mean a percent, is 20%, okay? Because it's 1 minus 0.2, which is 0.8. Write the exponential function that gives it after x years, so y is equal to 36,000 times 0.8 raised to the x power. All right, in recursive formula, that's going to be u0 is equal to 36,000, and then un is equal to un minus 1 times 0.8. What is the value of the automobile after 10 years? Well, where are we plugging in 10? We're plugging in 10 for x. So let's go ahead and plug in 36,000 times, I'm going to put in parentheses 0.8 raised to the 10th power. That is going to be $3,865.47. $3,865.47. And then we could check with the graph. All right, it hits right about there. And again, this is 4,000 right here. So it's right under that, and that is accurate. Use the graph to estimate when the automobile is worth 25% of its initial value. So when it's worth 25% of its initial value. Well, let's figure out that. So 36,000 is 100%. If we want to know what 25% of this, let's multiply it by 0.25. So 36,000 times 0.25, that's going to be 9,000. So we are going to subtract 9,000 from 36,000. Oh, oops, no, we're not. Okay, so $9,000 right here. What year is that? That's at about 6 years. And if I plug that into the equation, let's see if it comes out. I'm going to plug in 6 for x right there. So 36,000, we should get about the same thing, times 0.8 raised to the 6th power. Yep. When it's about 25%. All right, so that's the end. Thanks for watching.